Every message we send, every video we stream, every click we make is powered by something we almost never see. Behind our screens are data centers, the invisible engines powering our digital world. In one of the world's most connected cities, these digital hubs keep businesses running and communities connected 24/7. But rapid digital growth comes with rising energy demand, creating a new challenge for a low-carbon future. In Singapore, the data centers alone accounts for more than 7% of electricity consumption, with a projected rise to 12% by 2030.
We are seeing as IBM, there's a lot of digitization that is accelerating. It is crucial for us to kind of come up and say that the digital growth can happen, but that does not mean the energy growth will happen.
The Infocom Media Development Authority's Green Data Center Roadmap has set a clear direction for how digital growth can be more sustainable in the city-state by guiding the sector toward energy-efficient and greener data center practices. This means maximizing what existing data centers can deliver, rather than simply building more of them.
The key construct of this is how can you make software more efficient? And how can you have, say, efficient architectures which fit the business requirements and also kind of reduce the load on data centers.
With both land and energy limited, efficiency becomes the key constraint and the main opportunity for businesses.
From a Singapore standpoint and from a more, I would say, industry standpoint, we have proven, and I think there are a lot of proof points, that smaller language models, which are more domain fine-tuned and use much more less compute capacity, are better for specific use cases than a large language model. Because a large language model is fairly big, inference costs are larger, even training is very, very expensive.
Though traditionally, improving sustainability means upgrading hardware, software, especially with AI-driven optimization, is now becoming one of the biggest levers in reducing energy waste and how data centers operate.
Hardware as such, I would say, is capital intensive, so it's again slow to deploy. There are typical cycles in hardware. And whereas software can provide this incremental incremental innovation, which goes much faster. So in our case, in the green software trials, we worked with Yokogawa, a company where they wanted to kind of study how these architectural and software principles can help them reduce the whole and make the app more energy efficient. Okay, so principles like DevSecOps and other pipelines that we deployed for them help them reduce the emissions.
For companies running digital platforms, sustainability is no longer separate from performance. Green software and more efficient digital systems can strengthen both environmental outcomes and overall business competitiveness.
At Ant International, our products is inherently built on reliability and trust. Software design that lowers our technology carbon footprints is not just good for the environment, but it is almost essential to lower not just our costs, but also to enhance our resilience for us and for our ecosystem partners.
Global data center electricity consumption is projected to double by 2030, with AI workloads being the main driver. This growth is expected to increase 30% annually, outpacing traditional IT demand. It could also account for roughly 35 to 50% of total data center power usage by the same year.
AI scaling is not incremental, but it is getting more intensive, requiring massive computation, but also storage and grid power.
That is why public-private partnership is critical to ensure innovation continues, but without emissions rising alongside it.
Collaborating with IMDA on initiatives like the Green Software Trial enable us to break silos, bring the government perspective into scope, and understanding how we can actually work with our ecosystem together across different disciplines to build good, resilient technology, which can be implemented for large-scale platforms like ours. It's great to see IMDA is taking the leadership because government can set the foundation and the direction and convince stakeholders to build a shared infrastructure that is more sustainable and efficient.
By aligning policy, technology, and industry action, countries can shape a digital ecosystem that supports sustainable growth and innovation. In a world powered by data, efficiency is no longer optional. It is the foundation of competitive, low-carbon digital growth.